Continuing our study of quadratics, we're going to talk about solving quadratics using square roots. So the objective here, we've got quadratic equations, and we want to solve them using what's called the square root method, if you will. Okay, let's talk about what we know. Okay, we know from a previous video lecture, we know what a quadratic equation is. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a is not equal to 0. Again, a must be something other than 0 because you need the squared term in order to have a quadratic. If you have a being 0, this term is gone, and you're dealing with a linear equation, not a quadratic equation. The second thing we know is we know that the square root function is the inverse function of the square function. Okay, so we know that inverses undo one another. So square rooting undoes squaring. So if we need to solve something that has a square, we'll square root both sides in order to undo that and solve it. Okay, the square root method is pretty straightforward. We're going to use this when we don't have an x term. In other words, our b in our quadratic equation, I'll come up to here, our x term, our b is going to be 0. So we're only going to have an x squared term and a constant term. We're not going to have an x term. Okay? And so it becomes pretty simple. Okay, we don't have the x term, so we're going to set the x squared term equal to the constant, and we're going to solve it. Okay? Let's take a look. So here's the quadratic. X squared minus 5 equals 0. Okay, I'm going to just review with you. So we have x squared minus 5 equals 0. And we know, in this case, that a is equal to positive 1. The coefficient of the x squared term is 1. There's always an understood 1 there. We know here we don't have an x term, so b must be 0, because 0 times x would mean I'd have nothing there. And we know our constant term here, c, is equal to negative 5. So again, the square root method, whenever b is equal to 0, it's a nice thing to use. Okay, so we're going to set the x squared term equal to the constant. So I'll add 5 to both sides. And I have x squared is equal to 5. And then I'm going to use because x squared is equal to 5, and I need to undo a squared, I'm going to use the square root function because it's the inverse function that will undo it. So I will square root both sides. Now here's the thing that students tend to forget. When I take the square root of something, I always wind up with two answers, a positive and a negative possibility, because positive square root of 5 squared is equal to 5, and negative square root of 5 squared is equal to 5. Okay, so we always have these two possibilities. Okay, don't forget. Okay, so let's make a note of that. Two possibilities. Okay, don't forget you have two. So we have here, so in this case, x is equal to the positive square root of 5, or x is equal to the negative square root of 5. I have two answers. Okay, now let's do our check. Okay, we can always check our equations. Let's see here. Here's what we have. This was our original equation, so let's check first. How about when x equals the square root of 5? Okay, well, here's the original. So x, we're going to replace x with parentheses, and inside of those parentheses, I'm going to put the square root of 5. So the square root of 5 squared minus 5 Does that equal, it's a question, does that equal 0? Okay, well, the square root of 5 squared is 5. Okay, and indeed 5 minus 5, and that equals 0. So I know the positive square root of 5 works. Okay, now let's check the other possible solution. X is equal to the negative square root of 5. Again, I will use the original equation. I'll replace the variable with parentheses, and then I'll put inside those parentheses the negative square root of 5. So x squared is negative root 5 squared minus 5. Does that equal, question mark, 0? Well, the opposite of the square root of 5, or the negative square root of 5, squared, well, anything squared is positive, so a negative times a negative is a positive, and this comes out to be the same, 5 minus 5. The opposite of the square root of 5 times itself is positive 5. You can check that with a calculator. And again, 5 minus 5 is 0. And so I feel pretty good that I have two solutions, one of which is the positive square root of 5, and one of which is the negative square root of 5. So be very careful here when you're doing a square root to both sides. You're going to come up with two possibilities, a positive square root and a negative square root. We're going to see that come up again in the next couple of video lectures. Okay, another place where you see this take place, you can make use of this square root method, is in a situation like the one we see here in example 2. Okay, solve the quantity x minus 2 squared is equal to 16 using the square root method. Okay, because the left side is a square and the right side is a constant, or I could create a square equals a constant, I can use the square root method. Now, if I were to expand this, I couldn't use the square root method. I would have to use another method. But I'm looking at this left side, and I see my x is here, but it's underneath, it's inside of a squaring. So I can square root. Okay, so I'll take the original, and I'll say, hey, wait a second. If I just square root both sides, the square root is the inverse function of squaring, so I'll undo that. Okay, whoops, I didn't mean to do that. I'll square root both sides. I'll undo that, and I'll be left with x minus 2. The square root of a square leaves me with what is being squared, x minus 2. And then, of course, don't forget, this is plus or minus the square root of 16, which, of course, is equal to plus or minus 4. Okay, don't lose that. Positive or negative 4, when I take the square root, I end up with two possibilities. Okay, so I have x minus 2 equals positive 4, or x minus 2 equals negative 4. Again, I have two possibilities here. X minus 2 is equal to the positive 4. X minus 2 is equal to the negative 4. And I can solve both of these linear equations. In the first one, I'll add 2 to both sides, and I come up with x is equal to 6. In the second one, I'll also add 2 to both sides, but in this case, I come up with x is equal to negative 2. Those are what I think are the two solutions to this equation, this quadratic equation right up here. Let's check. Okay, we think one answer is 6. So we're going to take the original, we're going to replace the x with a 6. Okay, and again, we got parentheses going in parentheses. I'm going to write it with two parentheses. It might look a little bit more confusing, but I want to emphasize the need for parentheses, particularly when you see a negative 2. So the left side has a parenthesis. I'll replace the x with parentheses and put the 6 inside. So I have 6 minus 2 squared. Does this equal to, so I have a question mark, does that equal 16? And again, the parentheses aren't, necessary here. They may get a little bit complicated, but I just did that to emphasize how important it is to make sure you don't lose negatives. And so I use parentheses almost all the time, just to kind of be in the habit of it. Well, 6 minus 4, of course, is 6 minus 2 is 4, and 4 squared is 16. I can do that mentally, and I feel pretty good about that. Or you could use your calculator. So let's check our other possible solution, x minus 2. Okay, and let's see. Let's replace the x here with a negative 2. Okay, so I'll put in parentheses the negative 2, and I'll subtract 2, and the question is, question mark, does that equal positive 6? Oops, I forgot to square it. Okay, does negative 2 minus 2, the quantity squared, equal 16? Well, negative 2 minus 2 is negative 4. Negative 4 squared is indeed 16. So I have 16 equals 16. So I feel pretty good. I feel pretty confident that my two answers are x equals 6 and x equals negative 2. Okay, so that's the square root method. The square root method being most useful when your b term, you do not have an x term, you only have an x squared term and a constant term, your b is 0. And do not forget, as I say here, when you undo a squaring with a square root, you need to always make sure that you've noted you have two possibilities, a positive possibility and a negative possibility.